Hello students, how are you? I hope all you are fine. Myself is Amir Raza. Today I will discuss the very important topic classification of function of the chapter function. Function is also said to be mapping because map means to assign. I am taking one example. Suppose f is a function from a to b, then f assigns every element of set A to a unique element of set B. That is why it is called mapping. Suppose f is a function from A to B. First of all, I can divide into two categories, two groups. First group is one function or many-one function. One and many-one, and another is one-two and into. Why I am dividing like this? Because one function and many-one function are complementary of each other. Function can be one or many-one, but not both. Similarly here, function can be either one-two or into, but cannot both. One function is also said to be injective mapping and onto is said to be surjective mapping. Okay? So hence any function can be of the four different types. Function is one and onto, one and into, many-one and onto, and many-one and into. These four groups can be these four types. Any function can be of these four types. Okay. So first I will take the brief idea about these types, and then today I will discuss the one function in detail. As usual, you must have pen and notebook. You can pause the video and write down all the contents. I am taking one example. I am drawing the diagrams A to B. Suppose f1 is a function. This is the f2 function from A to B. I am taking just example to understand. This is here f3 function, A to B again. Here is f4 function. Okay. This is the f4 function. First of all, what is the difference between these two functions? Say these two functions. What is the difference? In both the f1 and f2, we see that in the codomain E is the extra element, means in codomain B it has no pre-image. But in this case, all elements of codomain are images. This is the difference. So this is called into function and this is called onto function. Onto function. This is into function. You can here, this all elements are images and one element is extra which is not the image. This is into and this is onto. ठीक है. In fact, हम बोल सकते हैं for onto function, codomain will be equal to range. Codomain will be equal to range. But for into function, codomain is proper subset of, range is proper subset of codomain. Range is proper subset of codomain, and for onto function, range is equal to codomain. I have got this point. Next point, next difference. What is the difference between these two functions? What is the difference? In this function, every element of domain has the different images. All elements have different images. One element has one image. But here, two elements are there which have the same image. Okay? So this is our one function. One function. And this function will be 1 and into. And what is this function? This is the many is assigned to 1, means many one function. Many one and onto function. And what is this? This function and this function. This is the 1 because every element has its different images. All elements have different images, but for this function, two elements have the same image, so it is many one. Finally, this function f4 is many one and into, and this is 1 and onto function. Have you got all these ideas? So this is the basic idea. Okay. Now, so that is these are the classifications based on what? According to way of assigning, how the function assigns the values to the elements of domain. Okay. On that basis, function is classified like this. Suppose I am taking one example. Question, write down the question. Find number of 1 function f a to b in the following cases. First of all, first case, we are taking two questions. Suppose a have number of n of a is 3, n of b is 4, and n of a is 4 and n of b is 3. In both cases, what will be the number of functions? Okay. Both are finite sets. A, B are finite sets. So first case, A, I am taking just example 1, 2, 3. Here 4 elements are there, A, B, C, D. What will the number of 1 function? We know that in 1 function, all elements of domain must have different images. Okay? Are you getting my point? 1 and many one both. Okay. All have different images. So if there are 3 elements, then this function must have 3 images. To select any of these 3, for any counting of a function, we are taking this as a place. In whatever the possible way in which I can fill these all places will be the number of function. In this case, 1 function, we must have 3 images. So I have to select 3 out of 4 here. So in what is the possible cases? 4C3, which से हम लोग select कर सकते हैं. Then suppose I select BCD, these 3 objects. I want to place these 3 objects in these places. So I can do it in 3 factorial. Okay? Or you can say this place can be filled up in 3 ways. This can be filled up in 2 ways. This can be filled up in 1 ways. In repetition is not allowed. So this is the 3 factorial. 3 into 2 into 1, that is 3 factorial. This will be equal to how much? 4 into 6, 24. There will be 24 1 function. This is the number of 1 function. What will be the number of many one function? So manual function will be number of all functions minus number of one function. Okay. So this is how much the number of one function I have to subtract from all the possible function that I can make. That I can make. See, for the function may be many one. So I have to arrange these objects in these places. We can repeat the objects. So it can be arranged in how many ways? This can be filled up in 4 ways. This can be filled up in 3 ways. This can be filled up in 2 ways. 24 into 3 into 2. Or you can say 4p3. 4p3 minus. No, not 4p3. Sorry. For number of function, I can just for a function, I can repeat all the objects. So it can be filled up in 4 ways. This place can be filled up in 4 ways, and this place also can be filled up in 4 ways. So yani 4 into 4 into 4, 4 की power 3 minus total number of one function, that is 24. This will be the number of many one function in this case. In the second example, case B, A has 4 elements. I am taking this example, and said B has 3 elements A, B, C, and I have to calculate number of many one function and one function. See here, domain has 4 elements. For one function, all elements should have different images. But there are only 3 elements, so I cannot have 4 images. These 4 elements, there must be 4 greater than 4 or equal to 4 elements must be present here. So in this case, number of one function will be 0, and number of many one function is, number of total function is how much? These are the places, and I have to arrange these objects in these places. I can repeat the object. So 3 ways, 3 ways, 3 ways, 3 ways इसे place को भर सकते हैं. तो 3 into 3 into 3, that means 3 की power 4. This will be the total number of function minus number of one function is 0. That means this is the number of many one function. Are you getting all this? You can write by pausing the video. Next. Now I will discuss the one function in detail. So, right here, one function. I have got the idea about one function. So in how can I say that about the one function? That means all distinct, I can write one line, distinct elements has of obvious word domain has distinct images. In one line I can say like this. This is the for one function. And what about many one function? At least two elements of domain has same image. Same, or image means value of function. Same value of function. At least 2 elements must have, domain must have same image. Same image. Then I can say it is many one function. So how to decide a function is one or many one? For this finding, I will discuss the 4 method. Method 1, and in this method I will try my best to prove that it is many one function. Try to prove many one function. What is this method? See here. I will try my best. Just I will take example, case, hidden trial, and I will prove. I will try my best to prove that function is many one. What is about the many one function? Domain elements of all the elements of domain must have different images. Means there are not even two elements in the domain which have the same image. Okay? If I guess and try that two function of domain has same image, that means function is many one, so it cannot be one. Suppose one person says that I am an honest person, then I will search his weakness. If at certain point of time he does the dishonest activity, then I will say he is an dishonest person. That's the method here, method 1. Just I am taking example, you will understand. Suppose f is a function from R to R, fx is equal to x square. Tell me whether it is function is 1 or many one. I am seeing here, I see here f2 is how much? 2 square, 24, and f of minus 2 is also minus 2 square, that is 4. That means at two different element, 2 and minus 2, function have same image, that is equal to 4. That means this function is many one. So it cannot be 1. I am taking more examples here. Second example, I am taking R to R, fx is equal to x minus 1 into x minus 2 plus 4. See whether it is 1 or many one. If someone find f1 equal to 4, one put कीजिए, you will get 4, and f2 is also equal to 4. That means what? f1 is equal to f2. यानी 2 point पे same image. That means function is many one. इसका मतलब cannot be 1. This is the method. Try to find the weakness. If at two different points, same image, that means many one function. Hence, it cannot be 1. I am taking different example, more tougher example, third number. fx is equal to e की power x minus e की power mod x by e की power x plus e की power mod x. It looks like different, difficult, but whether suppose f is same R to R, domain is R, codomain is R. See here, if I take x greater than equal to 0, then fx will be how much? Ex minus e mod x is x. For x greater than equal to 0, mod x is x. This is 0. That means what? For every value greater than equal to 0, function value is 0. That means f1 will be 0, f2 will be 0. Hence, at two different point, function value is same. That means function is many one. So it cannot be 1. Fourth example, x squared minus x plus 4 by x squared plus x plus 3. It's looking difficult. Okay? Sometimes I can equate function to some value. Okay? If it gives more than one solution, this equation gives more than one solution, that means function is many one. Suppose I am equating, but if sometimes it gives one solution, only one solution, that means I have to take another example. X squared plus x plus 3 equal to, suppose I am taking 4 by 3. Why 4 by 3? Because function ki value at 0 is how much? It is 4 by 3. So I want to find that any another number at which value is same as f0, 4 by 3. If it comes, then it will prove that function is many one. Okay. Then cross multiply 3x square minus 3x plus 12 is equal to 4x square plus 4x plus 12. Cancel out. And this is how much? X square plus 7x is equal to 0. Okay? And this will give x into x plus 7 equal to 0. That means x is equal to either 0 or minus 7. That means what? f0 is same as f minus 7. Hence, function is many one. It cannot be 1, 1. So, this is my first method. According to questions, we can select the methods. First method is very simple. Just take example and prove it is many one function, so cannot be 1, 1. Method 2. To prove 1, 1 function, and first method I can use in state boards, CBSE वगैरह I can use. Method 2. If I want to prove the function is 1, 1 and many one by this method, so I can prove like this. If f of x1, suppose function is a to b, f of x1 is equal to f of x2, f of x1 is equal to f of x2 implies x1 is equal to x2 for all x1, x2 belongs to domain. Yani for all elements of the domain, if for all x1, comma x2 of the domain, if f of x1 is equal to f of x2 implies this, that means what? What it is saying? That means if the function ki value same, image at x1 is equal to image at x2 is only same when elements are same. That means for another for different element you cannot have this equal image. Images are equal, it is only possible when elements are equal. Means for different element you cannot have same image. That means this function is 1, 1. Then function f is, name of function is f is 1, 1. Okay. How can I proceed that? I will take two elements. I will equate this and simplify. If it comes this, then I will say that function is 1, 1. Example. Suppose f is function r minus. Okay, I am taking small example first. F is suppose 0 to infinity. F is from this set to R, defined by fx is equal to log x base e, suppose. Okay. I will take let x1, x2 belongs to what? Domain of the function. I will add first this line and let function ki value at both elements are same. I am equating the function ki values, ranges, function images at these two elements. So f of x1 is how much? F of x1 is log of x1 base e is equal to f of x2 is log x2, f of x2 is log x2 base e. Since both sides log has the same base, I can eliminate from both sides. I can remove log from both sides. That means x1 is equal to x2. It comes like this. F of x1 is equal to f of x2 implies this. Hence, function is 1, 1. Function is 1, 1. Second example. If f is from r minus 5